In this example, I will show you how to find an oblique asymptote. An oblique asymptote occurs only if the degree of the numerator is larger than the degree of the denominator. Notice in this situation that the degree of the numerator is 2 and the degree of the denominator is an understood 1, since that x is to the first power. So oblique asymptotes only occur if the top degree is larger than the bottom degree. Now, if that is the case, then to find my oblique asymptote, I need to long divide the numerator by the denominator. That means whatever is in the denominator would go on the outside of my division symbol, and then whatever's in the top of my function goes in underneath my division symbol. Notice that we're missing powers in the numerator. So here this would be x squared plus 0x minus 5. Start the long division by looking at the x and the x squared. What would I multiply by x to get me x squared? Well, I'd need another x. Take this x and multiply it down. So x times x is x squared. X times 4 is 4x. Draw a line, change my signs. These two would cancel, and then I would have negative 4x, and I'd need to bring down a negative 5. Alright, at this point, I'd be looking at the x here and the negative 4x here, and say what times x would give me negative 4x? Well, I'd need a negative 4, and then I'd take that and I'd multiply it down. So negative 4 times x is negative 4x, and negative 4 times positive 4 is negative 16. Draw a line, change your signs. These two cancel, and then here we would have remainder 11. Now the remainder, I'll often write down here, who cares, because the remainder doesn't make a difference to my oblique asymptote. My oblique asymptote is only the quotient part of my long division, and so here oblique asymptote would be at y equals x minus 4. Notice that this is a linear equation. It has a y-intercept of negative 4, and there would be an understood slope of 1 over 1. So that would be my oblique asymptote.